Visit Chandra's beautiful universe. Abell 2146. Galaxy clusters are among the largest structures in the universe, containing hundreds of galaxies and huge amounts of hot gas and dark matter. Sometimes these gigantic objects collide with one another, and when they do, they release enormous amounts of energy, unlike anything witnessed since the Big Bang. These galaxy cluster collisions also provide scientists with physics laboratories that are unavailable here on Earth. A new study of the galaxy cluster collision, known as Abell 2146, uses a very long look, about 23 days' worth of observing time, from NASA's Chandra X-ray Observatory. X-rays are particularly important in studying galaxy clusters because they detect the massive amounts of hot gas that fills the spaces between the galaxies themselves. When researchers analyzed the Chandra data of Abell 2146, they found a shockwave that stretches for some 1.6 million miles. The shockwave, which is similar to a sonic boom created by a jet plane, was generated by the hot gas from one cluster pushing on the other. There is also a second shockwave detected behind the collision. Shockwaves like those generated by a supersonic jet are collisional shocks, meaning they involve direct collisions between particles. Near sea level, the Earth's atmosphere is dense enough so that gas particles typically travel only about 100 billionth of a meter before colliding with another particle. This is usually not the case in space. In galaxy clusters and in the solar wind, streams of particles blown away from the sun, direct collisions between particles occur too rarely to produce shockwaves because the gas has incredibly low density. For example, in galaxy clusters, particles typically must travel about 30,000 to 50,000 light-years before colliding. Instead, the shocks in these cosmic environments are collisionless and are generated by interactions between charged particles and magnetic fields. Collisionless shockwaves are important in several other fields of research beyond astrophysics. For example, the radiation produced by shocks in the solar wind can negatively impact commercial and military spacecraft operation, as well as the safety of humans in space. This study shows a deep connection between some of the largest, most energetic events and much smaller ones closer to home.